Let's derive the secant of x. Okay, so this isn't too tough of a derivation, it's just really knowing the mechanics along the way. But overall, this one isn't too bad, like I said. So let's get started. So we want to know the derivative of the secant of x with respect to x. Well, what's the secant of x? That's 1 over cosine of x, right? So let's go ahead and write it like this. So 1 over cosine of x. Well, now it looks like we can apply a little bit of the quotient rule. So, or all of the quotient rule. So, the way my teacher likes to show this is it's a little kind of saying. It's a good way of storing it in your brain. So I'll write it down. Maybe it'll work for you. Who knows? But it's low d high minus high d low over low squared. And you can probably figure out what this means just by looking at it, but I'll explain it anyway. So low is going to refer to our low function, our cosine of x in this particular problem. D high, derivative of the top function, minus high, the top function, times the derivative of the low function, all over the bottom function squared. So let's go ahead and apply this. You could actually, one quick note, you could actually derive this, the quotient rule, from the product rule with a little bit of the chain rule, but I think this is a good way of storing it in your brain. Just it's not too tough to memorize. So anyway, let's get back to the problem here. So yeah, let's apply this. So our low function, cosine of x, times the derivative of our high function. Actually, I don't need that. So times the derivative of our top function, which is 1. And what's the derivative of any constant? Well, it's going to be 0. So times 0 minus our high function, so 1, times the derivative of our low function. So what's the derivative of cosine of x? Well, we know that's negative sine of x. Alright, and that's all over, let me draw that line better. It's a little askew. Alright. So all over our bottom function squared. So cosine of x, quantity squared. Alright, so let's simplify this a little further. Well, we have cosine of x multiplied by 0, and that's, we can kind of just cross this off because that's going to make that whole term 0. So we have a negative 1 times negative sine of x. Well, that's just going to leave us with a positive sine of x. And then our denominator is just going to stay cosine of x squared. Or cosine squared of x, I should say. Well, that's a weird way of writing that. Let me redo that. Okay, so, well, we can break this down further, can't we? Because isn't this thing right here the same thing as saying 1 over cosine of x, 1 over cosine of x times sine of x over cosine of x? Well, yeah, because look, I mean, top times top, bottom times bottom, we're going to get sine of x over cosine of x times cosine of x, which is cosine squared of x, and that matches up well with what we got over here. So, well, let's think about this. So 1 over cosine of x is secant of x. So secant of x times, well, this is an easy one, sine of x over cosine of x. We know that's just tangent of x. So there we go. We've found or derived the secant of x, and that winds up being secant of x times the tangent of x. And like I said before, try to use this way of memorizing this. It's not too tough at all to memorize, and I like this little saying here that goes along with it. So there you go.